Welcome to section 7.6. We're talking about linear inequalities. Once again, talking about applications of linear functions. Today we're going to talk about graphing linear inequalities. So before we were talking about linear equations, now it's linear inequalities. So what is a linear equality? Two variables can be formed by replacing the equal sign with an inequality symbol. Now if you remember, you are less than, greater than, less than or equal to, or greater than or equal to. When we talked about one dimension before, say just an x is greater than 3, we had the number line and we had some endpoint at 3. So we'd have an open circle at 3 with all the numbers being greater than being on the right. So it wasn't just a single number where, say, you had x equals 2, where a single number made that true. It was a range of numbers. Now, in this situation, we're only dealing with one variable. We're talking about linear now, so we're going to talk about two dimensions. So if you look at something like this, you've got a linear inequality. You now have two variables in the mix. So the solution of an inequality in two variables is an ordered pair that makes the inequality true. So remember, your ordered pair is x comma y. So let's go ahead and see if these make this statement true. So let's go ahead and plug in 1 for x and 2 for y. So 2 is greater than 1 minus 3. You've got 2 is greater than negative 2. Is that a solution? Is 2 greater than negative 2? Yes. So this is a solution to that inequality. Now, if I've got a situation here where I've got negative 3, negative 7, negative 3 goes in for x, negative 7 goes in for y, so negative 7 is greater than negative 3 minus 3. Negative 7 is greater than negative 6. Is that true? No, this is not true. So this would not be a solution. So it's a solution if it makes it true. Now, when it comes to graphing these, we've got a few things that we got to keep in mind. The boundary. So this would be the line as we've done it before, except there's going to be a twist. So we're going to use a dashed line when the inequality is strictly less than or strictly greater than. That means that that endpoint is not included with it. If you think back to when we had less than or greater than, we dealt with an open circle. That said that, hey, it's up to that point, but it is not that specific number. Now, we're going to talk a solid line when the inequality is less than or equal to or greater than or equal to. So this would be the equivalent of the filled in circle, where you have a less than or equal to or a greater than or equal to, and you say, yeah, that number is acceptable. That is the endpoint. That is an acceptable number. So a dashed line and a solid line is something we have to keep in mind. Then what we're going to do, because it's not just simply numbers on the line, it's going to be anything above or below that line based on whether it's less than or greater than. So now when it comes to graphing these things, you're going to want to put it in slope-intercept form. And the first couple examples that we're going to do are in slope-intercept form. That is going to be the easiest way for you to graph these. So now, the graph of a linear inequality in two variables consists of all the points in the coordinate plane that represent the solutions. So if you look at this, and we want to graph this line. So we're going to start with our y-intercept, positive 3. So 0, 3 is where that point's going to be. My slope is going to be 4 over 1. So it's going to be up 4, 1, 2, 3, 4, right 1, up 4, right 1. We're off the charts a little bit, but that's okay. Or I can flip it around and I can say I'm going to go down 4, 1, 2, 3, 4, and I'm going to go left 1. And you'll see that these all fall on that line. 3, 4, and left 1. Now, before I connect the dots here, I need to take into account what this is. And notice that this is less than or equal to. So if it is less than or equal to, I am going to use a solid line. Solid line. So I'm going to connect these with a solid line. So this is as it was before with the equations. So that's okay. So this is a solid line. Now, this is where you're going to have to think a little bit. Y is less than that line. Y is less than this line. So what I want you to do is I want you to look at this line And I want you to think, what is the less than side? What would the bottom side of this line be? And if you look at the line and you think about the bottom side of the line, you would say that it's this side. So what you're going to do is you're going to lightly shade this side of the line. Now it's nice with the iPad because I can use the highlighter tool and do that. But if you have a pencil or a pen, you're going to want to lightly shade on that line. And you'll see why once we start talking about systems of these. But there you go. That is y is less than or equal to. It is a solid line, and we're shading the bottom side of it, that line. Over here, we've got y is greater than negative 1/4 x minus 2. So once again, we're going to start at our y-intercept at 0, negative 2. I am going to use my slope to navigate. I am going to go down 1 and right 4. Down 1 and right 4. Down 1 because this is negative, and right 4 because this is positive. So I'm going to go down 1 and right 4. Down 1 and right 4. And if I do it again, I'm off the charts. I'm going to flip it around, and I'm going to go up 1 and left 4. Up 1 and left 4, up 1 and left 4. And if I do it again, once again, I'm off the charts. So now, before I connect the dots, take a look here. There is not a line under that. So it is strictly less than. So this is where we're going to use that dashed line. Sorry. You can graph this by dashing a line as best you can. And I know when you're dashing, it's kind of hard to hit the dots. I apologize, but do the best you can. So there is a dashed line along that boundary. Okay. Now, what I want you to do is I want you to look at this, and I want you to say y is greater than this line. So our solutions are going to be greater than this line. This is the line we're looking at. What side of that would you say is the top side or the greater side of that line? If you said this side, you're correct. This would be the greater than side. So we're going to go in and we're going to lightly shade this side of the line. Because all the solutions, any number that you pick up here in this part of the line is going to make a true statement. Let's just check. Let's pick the point 0, 0. Easiest point that we can possibly pick. We're going to pick the point 0, 0. And we're going to plug it in, and we're going to see if it comes out true. 0 is greater than negative 1/4 times 0 minus 2, which is saying that 0 is greater than negative 2, which is true, so it checks out. Let's look down here, and we want to write it in slope-intercept form because that's going to be the easiest way for us to do it. So we might have to do a little bit of adjusting. So let's get that y by itself. We'll subtract the 3x from both sides. So I've got 2y is less than negative 3x minus 6. Divide by 2 to get the y by itself. Divide by 2. And I've got y is less than or equal to negative 3 over 2x. Negative 6 divided by 2 is going to be negative 3. So I now have my new linear inequality, and I'm going to go ahead and graph this one, starting with my y-intercept at 0, negative 3. And I'm going to use my slope, negative 3 over 2, to navigate. So I'm going to go down 3. I'm going to go down 3, 1, 2, 3, and I'm going to go right 2. Down 3, 1, 2, 3, and right 2. And I run out of real estate. So I'm going to flip the script. Instead of going down 3 and right 2, I'm going to go up 3 and left 2. Up 3 and left 2. Up 3 and left 2. So once again, as we've done all along here, you're going to notice that these are falling in a line. Take a look at what you have. This is a less than or equal to. Less than or equal to. So what you have is a solid line. Solid line that goes through all those points. Because it has that less than or equal to. Now, last piece of the puzzle. Y is less than, this is the line negative 3 over 2x minus 3. That's this line right here. And y is going to be less than. So take a look at the line. What side would you say is the bottom side of the line? If you said this side, you're good to go. So shade as best you can, lightly under the line. Any number over here is going to make a true statement. So you can pick any number, any coordinate pair that falls anywhere over there, and it's going to make a true statement. Now, what you can also do is instead of picking a number over here and knowing that it's going to be right, you can pick a number on the other side, such as 0, 0. And if it's on the non-shaded side, you know it's going to be wrong. So you can also check it that way. So if we go back to this original equation here, and if I plugged in 0, 0, this is going to be 0. This is also going to be 0. So that would be like saying 0 is less than -6, which is a false statement. So this point is not a solution, meaning we shaded the correct side. So it's testing it by using a number that you know is not a solution. So it's kind of the opposite, but just know that you can always pick any point over here and plug it in. It should make a true statement. If you picked in anything over here, it's going to make a false statement. We've got horizontal and vertical lines. So think back to graphing linear equations. We had a Hoy and we had a Vux. A Hoy was a horizontal line, has 0 slope, it's a y equals, and a Vux, which is a vertical line, undefined slope, and x equals. So when you're looking at this, think about that in that same way. X is greater than 1. X is, so we're dealing with a vertical line. X is greater than 1. Now this is going to be a dashed line. So it's all going to fall on this line right here. Let's see. Now, this one, there's not a top side or a bottom side. You're going to have to think about it a little bit. And if x is greater than 1, where are the numbers greater than 1? This side or this side? Well, if you said the right side, you're right. So this is what your x is greater than 1 is going to look like. It's a vertical line shaded on the right side, on the larger side. And then this is a Hoy, so it's going to be a horizontal line at y is greater than 2, and it's a solid line because it's less than, or sorry, it is greater than or equal to. So we know that this is going to be my boundary line. And now y is greater than or equal to 2, so you know that this is going to be shaded on the above side since it's greater than. That should be a little bit obvious for you, but y is greater than the line, so the top side of the line is going to be up here. Last piece of the puzzle here, say you're given a inequality situation here where you have the graph and you need to write it in slope-intercept form. You can go ahead and do that using everything you know about this. And what you can do is you can go in and you can say that, let's do this one. We know that we're going to write it in slope-intercept form, so we know that y is going to compare somehow to that line. And if you look at this right here, it is shaded on the bottom side of that line. So you can say that y is going to be less than that line. And I say less than because I know it doesn't look terribly solid there, so you can see that that is a dashed line, so it's strictly less than. Now, what is my line? I know that my y-intercept is -4, so I'm going to know that that's -4. I know that it's going to be some x. We just got to find out what that slope is. So find out where that crosses nicely. And it doesn't cross. Let's see if we can find them together here. No. Almost, but I'm going to say no. 1. You know what? That looks like a crossing because it looks like it crosses up right here again. So that would be a good one. So we know that it's going to cross right there. So let's use our rise over our run. Rise 1, 2, 3, and run over 2. So this slope is going to be 3 over 2. So now if you go back and you look at this and you say, all right, my y-intercept is going to be at -4. That's right over there. It's going to be a dashed line. We see the dashed line. And my slope is going to be 3 over 2. I'm going to go up 3 and right 2. Up 3 and right 2. Up 3 and right 2. And I'm going to shade below